2 points determine a line. If you look at how the coordinates of those points are changing on a line, so from one point to another point, well, comparing those changes in comparison in coordinates is what we call the slope of the line. So we always read lines from left to right. So if you look at the picture here, the red line is from left to right going up, so we say it's increasing. The green line, on the other hand, from left to right is going down, so we say it's decreasing. And in terms of the slope that measures this relative change of the coordinates, the red line has a positive slope and the green line has a negative slope. Traditionally, the letter M is used for slope, and so we could say M sub G for green, let's say, is less than 0. And on the other hand, M sub R for red is greater than 0. And keep in mind that those conventions are always used for graphs in terms of we read them from left to right. So if you look at any piece of a graph from left to right, if the y value is going up, getting bigger from one point to another, then we say the line is, or the graph is increasing over that interval. And on the other hand, if the y coordinates are getting smaller, going down from left to right, as you look at the graph, the curve, line, whatever, then we say that the graph is decreasing over that particular interval. For the lines here, since the whole nature of a line is that the slope doesn't change from one pair of points to a different pair of points, in that particular case, for a line or a straight curve, the slope is constant, stays the same throughout. Now, if we look at this brown line, and we think of it again in terms of the 2 points that determine this line, the 2 points are x equals 2, y equals 2.3. That's the point on the left. And then to the right, we have a point at 6, comma, -1, x equals 6, y equals -1. If you think of the slope here, the slope is negative because the line is decreasing. But also, one way to characterize what's happening with slope, if the slope is negative, that means that if one coordinate is increasing, the other one has to be decreasing. For a positive slope, the change in the coordinates will be the same for both x and y, and for a negative slope, the change will be different for x and y. So in this particular case, if you look at the line from left to right, x is increasing, y is decreasing. That idea of a change is sometimes represented by a Greek letter for D, which is called delta. Looks like a triangle. So delta x in this particular case, the change in the x values. Again, the convention is always to think of the x change as positive to move from left to right, at least if it's possible to do that. So in this case, if we're to make delta x be positive, more specifically, we could think of moving from the x coordinate of 2 to the x coordinate of 6. So we could think of that as kind of along here. Think of that as actually a horizontal line segment, but I don't want to clutter the board too much, but its length is 4 as you move from the point here at 2 to the point over here at 6. Now, as we do that, the line is going down, its coordinates are changing. So delta x in this particular case, again, is positive 4. The y values are changing. Likewise, they're going down, in this case, going down from 2.3 down to -1. So from 2.3 down to 0 would be, of course, a reduction of 2.3. And then to get down to -1, we'd have to go down another one. So that would take us to -3.3. So the change in y, delta y, is -3.3. The slope and for that, traditionally, again, we use the letter M from the French monter, to rise, to climb, to ascend, to go up. So the slope M is the change in x divided into the change in y. So delta y over delta x. People often refer to this as rise over run to sort of help keep the directions straight here. So the change in y, well, in this particular case, was negative. And since we're reading our lines from left to right, our change in x will always be positive. And so it'll be that change in y that determines the slope. We get -3.3 divided by 4. Now, depending on the context, you might change this to a fraction. I know it already looks like a fraction. Technically, it's a fraction, but when I say a fraction there, what I specifically mean is a rational number where the numerator and denominator are both fractions. So that could be written as -33 over 40 if you wanted to. And what that means is every time you go 40 units to the right, you go down 33 units. Depending upon the context, what you're doing with the slope, you could also use write the rational number as a decimal. So it's obviously negative. So let's see, 4 goes into 3. Oh, 4 goes, what would that be? Doesn't quite make it, does it? 4 would go into 32 8 times, so 0.8, 0.8, and then we still have that 1, so we go into that 2 times, and then what's remaining there? That would be 5, I guess. Let me do a quick check of my mental math. Should be able to do this, but I've been wrong before. Yep, -0.825. Or, again, if you, for some reason, wanted to write this as a fraction in lowest terms, as a rational number, you could also write it as -33 over 40. Now, there are 4 different possibilities. One possibility is the slope is negative, the line goes down. One possibility is the slope is positive, the line goes up. We saw that back here with the red and the green line. But of course, there's 2 other categories of lines. We could have a horizontal line. And if you're thinking that in terms of characterizing it in terms of how the y values are changing, delta y, well, if the line's horizontal, then the y values aren't changing. Delta y, the change in y is 0, and it turns out the slope is 0. So a horizontal line has a slope of 0. See if I can draw a horizontal line. What colors am I not using yet? A nice sort of burgundy color. So if the line's pretty much horizontal, near as I can tell, that looks horizontal. We have M. Oh, I forgot to change my drawing tool. Let's see. And that's what I'll erase that. Okay. So in this case, M is equal to 0. Maybe I should label that something or another. Brown, burgundy. I'll go with B. M sub B. And of course, the last possibility is that we're dealing with a line which is actually vertical. Something like that. And if that's the case, then our pink line, M sub P, well, The slope's not positive because the line's not going up from left to right. It's also not going down from left to right. And it's not zero, so the slope's not negative, not positive, not zero. We run out of numbers. Well, actually, if you think about what the slope means, it's the change in the up and down compared to the change in the left and right. Well, there is no change in the left and right in this particular case. The pink line is not moving from left to right. So y value, its x value is always staying the same. The equation for a line like this is something like x equals, what would be some negative number, anything I want, I suppose, negative 10. The x value is always negative 10. The y values change any way we want them to, but the x value is stuck at negative 10. Well, if there's no change in the denominator, that means the denominator is 0. Division by 0 is a impossibility, and so we say that the slope in this particular case is undefined. So that's a quick review of slope. And with the next video, talk about a few other things having to do with lengths.